Hey everybody, this is Larry. This is me going Cube 4 of the weekly contest 368 minimum changes to make case in my palindromes. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about this contest or this problem or whatever. So this one I actually solved like 2-3 minutes after the virtual contest, so it didn't show up in ranking, which is kind of sad. But to be honest, I didn't think this was a hard problem. But there are a lot of ways to do it, and there are a lot of tricky parts for sure. I mean, it's really hard to get it correctly implementation wise, but algorithmically, I thought it was okay. Well, the other hard part is, of course, just reading the problems correctly. And this problem is kind of really weird with the semi-palindrome stuff, but I don't know. I mean, that's just, you know. And I don't know that this is a note. It's like, hey, in case you didn't know, of course we don't know. No one knows what a semi-palindrome is. Don't put it on notes. Put it in the problem statement. What are you doing? Anyway, ranting aside, yeah, I think the way that I thought about it is just a lot of pre-processing, right? And or just processing in general. So we'll go over with code because I think there's really not much fundamental things about it. As long as you understand what a semi-palindrome is, then we can get started from there. But the first part of my thing is that I just calculate. Let me write it as I'm talking, I guess. Is to basically calculate for a given D how many changes needed from left, right, D, right? So basically left, right, D just means to calculate how many changes needed for for between that, right? And that's just to kind of like, and this is skipping D characters at a time so that we respect the D. Yeah. I definitely made a couple of mistakes here with respect to resetting score, so that actually ate up just enough time for me to get it correct, I suppose, in retrospect. But yeah, but this is very straightforward in theory. It's basically starts at the middle, and then it just kind of branches out left, right. So and this part is going to be the odd lengths, and I don't know why I put quotes on it, but nonetheless, too late. Even lengths, right? So that's basically the idea about this part, right? So I'm not gonna go over it, but basically just go one at a time or D spaces at a time, and then this is even length. So now you have even lengths and you at a time, and you calculate these things, right? Yeah, I don't think I'm gonna go over it, and here's the code. You could probably figure it out a little bit, and just kind of cache all the lookups, right? But yeah, after that, I kind of try to put them together, right? I think this part was kind of tricky for me to kind of get all the indexes and things correct. But the idea is now putting together, which is that start to end, right? So what does that mean? So the changes calculate changes from start to end, right? And what does that mean? That means that and we brute force it. Oh, and let me go over the complexity real quick so that I can kind of keep it up here. This one's going to be O of n cubed, right? This is O of n, this is O of n, this is O of n cubed, right? I mean, it's a little bit better in practice, but yeah, it's gonna be n cubed. This one, basically the idea is that for every D, we basically do a sort of a how do I say it? For every D, we basically just calculate as it changes the the number of changes in aggregate, right? Basically, given this lookup array, let's just think about this as and given a start, so we brute force on D, we brute force on start, so we can kind of now we just looking at the only thing that changes is the right? So that means that without loss of generality, we just have like some whatever, right? So then now start is going to be the first one, and D is some number, right? So now for D, all we have to do is just calculate, the sum of okay, say this is group 1, and this is group 2, and then now for every space, now for example, now we know the quote unquote the distance from between these two, and then now we just kind of keep on adding to it. And for this A, we say, okay, now we have 1 and 2. And here, actually the way that I did it is that the start is a lie a little bit. Is that, yeah. So then now this adds the 1, and then calculate the score for this, but only for the ones. And then for B, same thing as well, calculate the score for this, but only the B. And then so on, 1, 2, 1, 2, and then we just keep on calculating. And the way that we do that is just by keeping track of the scores mod D, and then we just kind of use the first lookup table that we have to calculate, to figure out the new value, and then we subtract out the old value so that we get the new score. Keeping in mind that it is not like monotonically increasing or decreasing or anything in any way. There's no real pattern, because now, in theory, you look, I mean, let's say D is equal to 1. We're first looking at A, and then AB, which has some added change score, and then ABA is going to go to 0, and then AB as a palindrome, you have to change 2 things, I think, and then ABA goes to 0 again. So you have to kind of do a lot of these things to kind of keep track of everything, right? And this is the code that does it, is that, yeah. And I just want to, and basically I only save it if the length is a multiple of D. This is kind of just given in the thing, but otherwise we save too many things. And also that this one is just to make sure that we have 2 characters, right? So you don't just do like the default 1 character thing. In that case, it means that D is exactly equal to length, right? So if D is equal to this, then, you know, so here we just kind of make sure that it goes over that. And yeah, and then after we calculate all these changes, now we can just use a very standard longest path in a DAG, right? So this is, for this part, I think this is probably the easiest part per se. So I'm not going to go over it that much. Suffice to say that if you're weak on this part, it's probably the part that you should work on, and there are plenty of problems that are kind of using the similar idea with dynamic programming. Did I say shortest? Yeah, shortest path in the DAG, right? But also just like regular brute force, if you will, dynamic programming. Index is going to be, you know, the suffix of the problem that we're solving. And left is just equal to the number of partitions left, right? And that's pretty much the idea. So basically we have to take at least 2 characters at a time is what we're doing here. We figure out the score, aggregated, you know, number of changes for the 2 character or more things, and we also just you know, do recursion based on that, and that's pretty much it. Like I said, I'm not gonna go over that much this part. This is also n cubed, right? Index could be n, left can be n, and we do an n loop, so this is going to be n cubed. It's slightly better than that in practice, but not in a big O kind of way. Just like the constants are kind of better, I suppose. I don't know, I missed this part as well. This is also n cubed, in case, you know, because you can kind of see the loops n, n, and n. Like I said, this is actually slightly better, but you know, cool. Yeah, that's what I have with this one. I think, like I said, the algorithm part is not super hard per se. If you're able, well, the hard part is that you have like 2 or 3 things, or maybe even more. You have these ideas that you have to put together. But in terms of like the difficulty of each individual parts are probably okay. But it is kind of very hard to kind of put all 3 together. And I took forever, right? So I'm not trying to make it sound like, oh, this is easy. But, you know, I didn't even do it during the virtual contest. I did a little bit after. But I think a lot of it was, for me anyway, an implementation. And just like a lot of minor things that I was just a little bit wrong about. Like, for example, this part, the delta thing, I didn't really... I thought, for some reason, I thought I could just min... It was a min over a substring instead of sum over substring. But once you have this, it's, you know, straightforward. And in theory, you could even do other crazy complexity things. but this is all one, right? So yeah. Anyway, that's all I have for this one. Let me know what you think, and yeah, let me show you the top, the middle, and the bottom, and that's all I have for this one. Let me know what you think, and yeah, stay good, stay healthy to good mental health. You can watch me solve it live during the contest now. This one, I feel like, I don't know, just struggle more than I should on this one. Let's see. Minimum changes to make case semi-palindromes. Oh no, is this some like, was it C algorithm or the other one? Managers. String S and integer K for this, and 200. Maybe it's DP. Maybe I don't have to do something crazy. What's a semi-palindrome? Okay, we know what a palindrome is. It's just a number D such that one is less than or greater D, or the length mod D is greater than 0. Man, this is the stupidest way to write like no one understands this. Can you speak English? Length mod D is greater less than 0. Okay, so D is D is okay, and then if we take the same indexes, have the same modulo by D, this is not an explanation though. This is just like, oh hey, these are things, and these are substrings. Okay, and this is not a note. This is literal. This is in the problem. Why is this a note? Like note. Hey, do you know that this is the problem? Like you have to define stuff. Put it before the note. This is a very silly decision. Okay. Anyway, so if D is 1, what does that mean? Same model. Okay, so it's every D character. So this is, yeah, they could have just explained it that ABA is divides into AA, or well, ABA, if D is equal to 1, it's just ABA. Why is A not? Oh, because D is not greater than length. Okay, fine. This is why, because for D is equal to 1, that's not good. 2, it is not good. 2 is just D, G, D. Oh, 2 is good. Okay, fine. This is a very weird problem. Okay, fine. I understand it now. Maybe. I don't even know if that's true. Okay, what minimum number? Oh. Each substring. What substring? Oh, K substrings. So we have 2 substring. We get divided into A and C. We turn AB into AA. Okay. Is it DP? I don't even know how DP works. So okay, if D is equal to 1, then the string has to be palindrome of length at least 1 or 2, I guess. If D is 2, is every 2 characters. TGT. And there's this fly that just won't leave me alone. So if you do DP, what does that mean? What can we do each character? This is a hard set for me. How many people have gone Q3 so far? a lot of people. It seems like. So maybe I just don't understand this file. Like 100. So maybe not that many actually. But okay, so it has to be at least 2 characters because there's no one character D. Okay, if it's 2 characters, what does that mean? And I guess they kind of highlighted here, but what? Two characters. Well, if it's 2 characters, it has to be the same. If it's 3 characters, it basically just has to be. What is 1 again? Oh, 1 is the same. So it has to be either palindrome or what? D is equal to 2. D is equal to still mix it a palindrome for character 3. For 4, I guess D equals 2 is equal to. Is it a D equals 2 thing? D equals 3 thing? How many substrings are there? Okay, the 200 choose 2 substrings. What's 200 2? So 200. So we can pre-calculate for each of those. We can calculate all the D's. 200 cube. Well, divided by 2, and then I wish this isn't. Python is kind of scary to do, but I think maybe because it's 200. Should be no times C. Okay, should be fast enough maybe to brute force it. Okay, let's take a look then. And this has to be at least 2 characters, so we should start by I plus 1, right? And then now score say yeah, okay. And then now score sub ij is equal to calc of ij, right? I guess I could just cut. This seems like a manual memorization, but okay. Left, right. So then now the size m is equal to right minus left plus 1, right? So then now we brute force min is equal to infinity. And then now, yeah, for, I don't know, did it go D in range of M starting from 1? So yeah. This is 200, 200. This is really slow, isn't it? Huh. So we have to kind of do this in a sliding kind of way. Maybe. We have to do an optimization here. For D is yeah, this is too slow the way that I have it right now, but we can maybe change the loop a little bit so we can do something like that maybe. But then what does that look like? So I is to start. Okay, fine. Right. And then so for D is equal to 1. No, it's not that they're all the same. Wait. Yeah, it's that you have to. It is the miniatures, maybe? Is that the one? Let me go to miniatures. I'll go. Is it the longest? No, is that what we want? Alright, let's look at it inside out, right? For D is equal to 1. Okay, yeah, we have to look at inside out, not left, right. For D is equal to 1, then for start is equal to, I don't know, same thing, right? And then we just calculate left and right. What happens if D is equal to 2? Can we combine two numbers? Yeah, I think so. So then this is going to be n cube-ish. But that should be okay. Just a lot of... this is very annoying to get right. And then now I have to figure out Q3. But let's figure out this one first, because at least I have an idea. Okay, so then... yeah, suppose you go to 0, right? Yeah, let's just say, I don't know if this is going to be fast enough, or even use too much memory. Okay, let's see, right, so and then it just becomes shortest path in the DAG kind of thing, which that part is fine. Yeah, okay. This is hard. So okay, so okay, so right. Okay, and then now while length left is greater than 0 and right is less than n, then we go okay at the end minus left by d, right, with d, right. But before that, if s of left is not equal to s of right, then score increment by 1. We also want to do lookup of left right is equal to score, right? Okay. Let's print lookup real quick. And the real reason why I want to test this real quick is for TRE. 0, 0, 0. Okay, fine. This looks good. And I missed a thing. Actually, that's why the space is good. Okay. We only want to. So for 5, for the number 5, right? Let's say the length is 5. Oh no, it has to be mod is equal to 0. Okay. So that means that if d is equal to 1, that should be fine. But if d is equal to 5, then no, it's always going to be fine. It's just that if they're the same number, that's silly. Right? Okay, yeah. Okay, maybe I can do this instead. Okay. Yeah, that is better because we never care for the same character. Is that true? Because that means that there's at least 2 characters. Do you ever want to use d as less than n over 2? Yeah, I guess so. If you have like a b a if you have something like a b a b a b, if you use 3, then it's going to use a b a b a b a b a b b a b, which would take 3, but of course you can just use 2. If we use 2, then it's AAA and BBB. Okay, yeah, fine. So that I don't know right now how to do this, but and I don't know if I'm doing this right. I mean, I think the idea should be right, but it's very hard for me to prove. Okay, let's at least do something like if right minus left plus 1 mod d is equal to 0. What does that look like? And this fly is giving me a very annoying massage. Okay, that looks fine. But all the d is 1, so why? 2 away, 2 away, that's going to be 4. Okay, fine, not the plus 1. What does this mean? That means that it's always divided evenly. Oh yeah. I think this part is fine because we're not doing even numbers. These are only odd numbers and we don't have enough things for now, right? Then maybe it'll be better. Okay, yeah, there you go. Wait. Definitely does not do d is equal to 2. Or d is equal to 3. No. Why not? That's the length including the thing. Oh, of course it's not because it's an extra one. Length is divided by d means that yeah, okay, I guess we don't need this. Because it will never be modded by d, it will just be that plus 1, but then that will always be true, fine. Okay, and then now the other thing, which is the even numbers, or the even length palindromes, and left is equal to start, right is equal, or maybe start plus D. This is so easy to get wrong. I mean, I think the idea is fine if it's fast enough, which I'm not sure it is, but we can just do something like S is equal to 8 times 200 or something, right? So this actually seems fast enough somehow, but because then it just becomes longest path in the DAG, which is fine. Is that even true? Maybe not even. I don't know. Now that I'm thinking about it, the longest path in the DAG is a little bit awkward. I mean, but this is a little bit okay. I mean, this seems actually one pretty fast, faster than expected. But let me double check this real quick. Only 36. But it's just, this is so hard to kind of phrase out. Which then now it's just longest path in the DAG, right, in theory. But then now to kind of merge all the mints, right? And maybe we can even do that preemptively before, so maybe we can do that. Okay. So let's just say right, for start in range of n, for n in range of start plus 1n, right? So then now the length so L is equal to n minus start plus 1, and then now for D in range of 1L, if L mod D is equal to 0, maybe the Sif Eve thing would be fine, right? So then now you want to take the min of n elements, don't you? And then here, in theory, you could do some min q thing. How much time do I have left? Actually, I don't even know. 38 minutes. Wow, spending an hour on this. Huh. I have to think about it's all about analysis. I was just YOLOing a little bit because I've now have to do Q4. This was a mess. Messed? I can't even speak English right. This is a mess. How many people got Q4 so far? I feel like the way that I'm doing it is right. It's just, well, maybe, I don't even know. It's just way hard. Because, okay, now we pre-force this, and then now we do a sort of sliding window thing, right? And then now, what does this look like for sliding window? Yeah, okay, fine. No, I think this is fine. So then, so for 1 is equal to L. No, the length is not. Can you do a sliding window thing? Because the length is not quite there, right? And then this isn't even quite right per se. How do I structure this in a prefix? So let's say D is equal to 1. Alright, fine. And a start, right? Let's say we write it this way. And then what? And then now, let's say D wants to be 2. So then D being 2 means that start but then now it has another D factor, right? So, man, this fire is really annoying me. Like, what are you doing? Go anywhere else. Okay. All right, so D is an L means that means that there are D groups, and we're trying to find the min of all these 3 groups, right? Okay, and that's for only odd lengths. So you have to do at least 2 characters each, which is fine, but yeah, okay. So then now, okay, so let's say we start at here, right? Scores, let's just write something really naive and then we'll figure it out. Times D, right? And then from the start, we want so we want start and start. Oh, so for new DD for delta D, I don't know. So D, right? Then now scores of start plus scores of DD is equal to min of scores DD, and then some lookup of start start plus DD, start plus DD plus D, and then D, right? I mean, this is kind of right, but I think now we have to loop through another thing, so that becomes 200 cube or something. So I don't think that's quite right. Is that true? And then score of what D lookup of so something N and D, it's going to be like N minus D is that true? What am I doing? It's not, I don't know that palindromes work quite like that. Or like, at least the way that I'm doing it is not making it any faster. So okay, so this is the offset. Let's do it. So this is it's not start plus offset. It is start. The start would be 0 offset. So it's going to be, oh no, that should be start plus offset then. Something like that? I don't even know. I mean, running time, it seems fast enough somehow. Even though I made this into a 200 character thing. I gotta remember to return, well, I'll return the wrong answer, so it'll be very obvious. And then lookup of 2. So then now min is equal to infinity, min is equal to min of scores of offset min. So the way that I'm doing it, I don't even know that it, because I think this isn't quite right, this is in the min. There's no sliding things here, it's just this, I think. And then lookup 2 of start n is equal to min. Right, let's see if this is anywhere even close to right. How much time do I have left? 20 minutes. I mean, if I am right, it should be close. It might not be. 0, 1 is 0. I mean, everything is 0. It's not very inspiring. Is 0, 1 enough? 5. I do want to see some. I mean, they're all zeros, so that's not great. Do we want the min of these? No, we want the sum of these. So it's not a min. Score is good. Why do I have these things? Okay, I see, but fine. I think I wrote it another way, right? Because we want the sum of the deltas, not the min of the deltas. Then now this is this, right? So previous is equal to scores of offset, right? So then now we have one score. We want to add the offset, and then we want to minus the whole score, and then this is the score. I mean, still not giving me bueno, but it's lookup all zeros. Why is this so weird? Oh, lookup of course is all zero. Wait. Oh, because I did. This is fast because I did n before the thing, and also these are all zeros because actually, this should be all zero because they're all the same characters. Okay, so at least this has some other stuff. Are they right stuff? Don't know. Definitely something feels wrong because 0 to 3 should not have 5 as a cost, no matter what. Right? Oh no, this is lookup 1. No, but how is this a 4? Zero 1 is a 1. That's fine. Oh no, 0 1 1 is a 4. What? Oh, I have this reset score is equal to 0. New. Okay. Now it looks a little bit more correct. I don't know if this is right, but it should be more correct. And then now we're gonna look up 2. Hopefully they're all less than 1 now. This is still very wrong because this should still never be 5, pretty much. Do I reset everything this time? Starting at 3. What am I printing? Okay, this one. 0. So from 0 to 1 is going to be 0 1. D is 1. Okay. Lookup is 1. That's fine, probably. I don't know if it's true. But for D is equal to 1. What does that mean? D is equal to 1 means that every character. Okay, so that means that AB is gonna bring change 1. ABC also change 1. That's true. This changed 2. This changed 3. That's probably true. No, that's not true. That's just 1, right? 0 to 4. Zero, 4, 1 is. Let me look at that. Oh, it's this one. No, 0 to 4 is 1. The lookup is wrong, isn't it? I mean, I don't know about lookup. But 0, 4, 1 is 3 is wrong. Why is it wrong? So 0, 4, 1 would start at 2, right? I don't start anything weird, right? Zero, 4. So much debugging. Let's remove the other one. It's 0, 4 is 3. Okay, why? 2, 2. Well, 2, 2 being 1 is definitely wrong. Oh no, I do not know how to reset score because I am a noob, apparently. Okay, fine. Did the same mistake twice this problem. I guess it's consistent. Not in a good way, but consistent. Okay, 042 is 041 is still 2, which is still wrong. Okay. 2, 2, 1. And then A is not equal to B, so that's 1. And then A is not equal to... Oh, actually, yeah, I guess that's... Yeah, okay. 2 is right. Okay, fine. Cannot... It's not even meant... Just... Now we're being dumb. Okay, now it's putting too much. Don't know what to do with this, so let's... Okay, let's say lookup is finally correct. Let's look up 2 better. At least the sanity checks looks okay. 0, 4 is 1. Seems a little bit low, but... yeah, it definitely seems low. Zero, 4 of 2. Well, you can't really do 2 of 0, 4. So I think that's the 4 in one of my things. Or like... I have to do something like... Oh, and it should be a min, I think. But still, if n minus start mod d is equal to 0, that's the length. Nope, has to add 1 more for length. I mean, this is at least right. Is it now? Wait. 042 is. You can't do 04. Is that right? Why does this print this? Oh, I print everything anyways. So. And this should be a min, maybe. Yeah, this should be a min. Okay, so then now 0, 4 tries to do 2. That's fine for k is equal to 1. And 2 to 4. 2 to 4. K is equal to 2. Or D is equal to 2. I guess that's fine actually. No, wait, is it? 2, 3, 4, that's 3 numbers. So why is it printing out these things? There are other print statements? No. Oh, okay, yeah. This is not the thing. That's just this. The 2 to the 4. Okay, yeah, that's just the length. Okay. So 0, 3 is 1, 1 to 4 is 0. Is that true? That's not true. With 2, is it going to be 0? No. 0, 3, this is being 1, it should be fine. But this is wrong. Why is this wrong? Is equal to lookup of 2 start offset. So it starts at 2 to 4. 2 to 4 of D is equal to 2. That means 2 characters. I mean, this being 0 is fine, because what this is saying is that this is just matching the 2 and the 4. Okay, and then now, so this is 2 to the 4 is 0, is this part is wrong, right? I mean, yeah. Like this part is fine, but then the score is wrong. That's the biggest issue. Wait, what? No, that's 2 to 4 with 2 to 4 has 3 numbers, and 2 to 4 is, oh, I see, because we haven't done the, in theory, 3 to 5 yet. So we have to 2 to 4. So we can only update this if every number has gone once, which means if n is greater than or equal to start, or if start plus offset, or if offset is greater than or equal to D, then we've looped once. Okay. Okay, maybe not. Well, this cannot be because of the mod D, but if n minus start, okay. So now 1, 4 should not exist, or 2, 4 should not exist, but it's still here. Because n minus D, no, start minus n is not quite right. Start minus plus D, right? Because of the n, well, by default, n is going to be start plus D, so that's just silly. It's this, yeah, okay. Okay, still wrong. Oh, whoops, wrong side. Or minus D, I guess I have one. Right, is so. Okay, so this is still wrong. I cannot understand this problem. Okay, fine. So the start is 2, n is 4, so that's gonna be 2. If it's greater than d plus d. Oh no, this is for d is equal to 1. Okay, I could buy that. Okay. Yeah, okay. Actually, that makes sense. How much time left? 5 minutes. I'm not gonna finish this. But just too long on the debugging. But yeah, okay. Let's just YOLO the rest of it, I suppose. Right. So then now, whatever index left, right? So go 0 and was it k? K. If index is equal to n, if left is equal to 0, we return 0, otherwise we return infinity. Yeah, is k greater than k can be 1? Okay, fine. So then now for I in range of index plus 1 n, right? Best is equal to min, best go I left minus 1 plus lookup of 2 of start of index, or start from index to I, and then yeah, in theory that should be it, but whether it's fast enough is another story, obviously. And apparently we return infinity for some reason. Yeah, if f is equal to 0, we return infinity, but that shouldn't change that. Oh, look up, this may be infinity as well as by y. But why? Assert lookup 2 of index I is not infinity. Okay, I thought that this should take care of everything, but is that true? Possibly not. Let's see. Oh, I'm missing 0, 1 for some reason, for example. Why do I miss 0, 1? 0, 1. Oh, you have to have at least 2 things, so okay, so index of 2, right? And then this is I minus 1. Yeah, okay, fine. I mean, I have to get rid of this still, I think. I'm watching a little bit because I have like 3 minutes, but you know, I know it's not a hard thing, like a hard deadline, but why am I, or why, what was wrong with this? Well, this doesn't go all the way, is why. Okay. That's on the return value, right? So it's always possible. I guess it always is possible. Best should be just maybe n minus index. We change everything. It's gonna be wrong, but at least it's giving me something. 2 for the first one is wrong. These are all wrong actually. K is equal to 2. Why? Let's just do something naive real quick. Okay, 0, 2 is going to be, this is the 1, right? This is 1. Okay, so, wait, what? Why? Oh, that's left. So, so we could go to the suffix of 2 is 0. So then 0, 1 is what? 0, 1 is still does not exist. Larry, that's why. Why does just 0, 1 not exist? Is this like -1 or something weird that I messed up? Okay. 1200 is, if that's, I don't know if this is right, but we literally have like 2 minutes left, so we're gonna have to YOLO. Not even 2 minutes left. Let's, okay. I mean, it's right for these, I think. I don't even know what the last case is. Actually, I don't know if this is right for the last one, but let's give it a submit. If this accepts, it would be miraculous. But it maybe, oh, I was gonna say maybe it times out, but okay, fine. This is a little bit worse. I think the idea is right. I don't know if it times out. That's another story. We can actually check that though. But I just had no time. Now we ran out of time anyway, so I just might as well be a little bit responsible. I was just a little bit YOLOing. So it times out anyway. Ooh, maybe not. I mean, it's still very slow, but maybe it doesn't actually time out. But it is wrong, so you know, even if it doesn't time out, if it's wrong, it's not great. Two means we have a mistake somewhere, either an algorithm or whatever, because it's better than optimal, right? Which is impossible. So it's not, or it's not only an algorithm thing. Even if the algorithm is right, the implementation is wrong somewhere, like an off by one or something maybe. Let's see, 3. What we want to choose. The answer is 3 changes. How? And we ran out of time. Disastrous. Wasting my Hong Kong time here. 3 groups. Oh, 3 groups has to be DQ, PL, DQ. So that has to be 3. Okay, that's fine. In theory. How do they even get 2? Okay. So 0 to with 3 left is 2, because 5 with 2 left is 1 is gonna be not true. You just don't have enough letters. Getting a phone call. I don't know if I'm supposed to get a phone call in Hong Kong, so I'm just gonna ignore it. Maybe it's spam already. Okay, so there's definitely at least something silly. With 2 left, 5 should not be possible to be 1. Right. It's already terminating on something weird. Okay, 5-2, right? 5-2 doesn't call anything, does it? It just returns 1 for these for some reason. Oh, because of this thing that I had earlier, which is not true for this. Okay, well, I mean, if this is right, I still consider more victory, even though that's a very silly. I kind of got out of it so I could kind of visualize a little bit better with but I mean, it may time out still. Hopefully not a wrong answer though. With times out, I have to think about what to do. Oh wow, I got accepted, but a little bit late. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this farm and this explanation, all this stuff. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.